We're going to go ahead and take a look at rational exponents. Remember, rational, the root word of rational is ratio, which means you should be able to write it then as a fraction. So we're going to look at exponents that end up being fractions. We've done a little bit of that in the past, but we're going to do more of it in this lesson. Now, just as a reminder, if you have a negative exponent, that means you move it to the other part of the fraction. In this case, it's really over a 1, because there wasn't anything written there. So you can move that negative exponent down to the bottom, becomes a positive exponent, and it would leave a 1 on the top. Now, as we look here, we've looked at this a little bit in some of the previous lessons. We had said a square root is a 1/2 power, or a cube root is a 1/3 power. So whatever root you have, it's really a 1 over that power. So the nth root of b is really b to the 1 over n. Now sometimes you have an exponent that's being applied to that root. Well, if that exponent applies to that root, you'd have the nth root of b all raised to the n, m, so it would be a b to the 1 over m, all raised to the power of m. Well, then you'd have to multiply your exponents, and then it gives you this. So in other words, when you have a fractional exponent, the bottom part of that exponent tells you the root you're taking. The top part tells you the power you're raising it to. Now, whether you take the root first and then raise it to a power, or raise it to a power and then take the root, really doesn't make a difference. You can do it either way. So here we have the 1/6 power of a. Writing that in terms of a root would just be the 6th root of a. Or here, this would just be the square root of m. So we want to do the same type of thing down here. Just write them from one form to the other form. So this would just be an x to the 1/4. This would just be the 6th root of a, just like we did up here. This would just be y to the 1/3, and this would be just the square root of m, like we had up above. So we're going to now simplify problems using fractional exponents. It's a negative, so I'm going to go 1 over that. So it's going to be 1 over 49 to the 1/2. Now remember, the 1/2 power really means the square root, so it's 1 over the square root of 49, and wow, that's just a 1 over a 7. The bottom works out nicely. Here, I have the 5th root because I have a 5 in the bottom of my exponent, and then I have to square it. Now, I could go ahead and square my 32 and then take my 5th root, but I don't know 32 squared off the top of my head. That'd be a relatively large number. You could go ahead and think of it as the 5th root of 32 and then square it. Well, that I can do because I know the 5th root of 32 is just 2. But then I still have to do the squaring. Oh, well, 2 squared, that's easy to do off the top of my head. So many times it's going to be easier to apply the root first before you do the exponent. Because you're dealing with smaller numbers, you can do them in your head. So try these two problems quickly and then watch the video. Negative exponent means I put it in the bottom. A 1/2 power means the square root, and the square root of 25 is 5. Here, I'd have the 4th root of a 16 cubed. The 4th root of 16 is a 2, still have to cube it, and I get 8. And that's what my son did with his breakfast, is he ate it. Did you know why some numbers don't like other numbers? Why doesn't 6 like 7? Because 7, 8, 9. Okay, back on task again. Y to a power times y to a power. Well, just like what we've done before, y to a power times y to a power, you just have to add your exponents. And in this case, it's nice because we have a common denominator, so you add the top, keep the bottom the same, and we get this here. Now, we could write that as the 7th root of y to the 5th. Typically, though, as you look at the problems that you'll be doing, if you start out with rational exponents, you want to leave your answer with rational exponents. So we'd leave it as this. This is not necessarily technically wrong, but for the most part, with what we're going to be doing in class, if you start out with rational exponents, your answer should be left with rational exponents. If you started out with your roots, you'd want to leave your answer with roots. So try this one here. Oh, a negative exponent puts it down in the bottom. Oh, you might not know what to do with that. Well, you could change it into roots. That would really be the cube root of an a squared. Well, now this looks like problems that we've dealt with in the past. We don't want to leave roots in the bottom, so you have to multiply by a special form of 1 because you want to try to get this in the bottom because you want your cube root to cancel out your cube power. So you got to think a squared times what is a cubed? Well, that's just a normal a. So you multiply the bottoms, multiply the tops. Well, the bottom simplifies, the top doesn't, and we would have this. Now, if you started out with roots, you'd leave your answer as this here. But we didn't start out with roots. We started out with fractional exponents. So you're going to leave your answer as this. So just because you start out with fractional exponents doesn't mean you can't change it into roots and work with it as you're more comfortable with that approach. And then you can just change it back. So try these two problems quickly. So we can add our exponents, and then we get our answer. Now, could you write it like this? Yes, but we're going to leave it like this because we started out with fractional exponents. Negative exponent puts it in the bottom. Well, that's really the fourth root of an a cubed in the bottom. Don't like to leave roots in the bottom. Multiply top and bottom by the fourth root of a. Gives us the fourth root of an a to the fourth in the bottom, which simplifies down to this. Now we started out with fractional exponents, so we want to leave our answer with fractional exponents. So this would be our answer. So looking at this one, we can't really simplify top and bottom at this point because our roots are different. Now, you could think of the bottom as a fractional exponent, and you could also use fractional exponents in the top. You could use a 1/6 power. Oh, but think of 16. That's either a 4 squared or a 2 to the 4th. Well, typically you want to go with the smaller the exponents if you can. So I'm going to go to 2 to the 4th. Well, now it's just an exponent raised to an exponent, so I just have to multiply those. So then I get a y to the 2/3, and oh, that's not y to the 2/3, that's a y to the 1/3. And then 2 to the 1/3 over 2 to the 1/3 is, wow, some days the brain doesn't work right. Yes, it is a 2/3 power, and while 2 to the 2/3 over 2 to the 1/3 is just a 2 to the 1/3. Try these last three problems on your own and then watch the video. So on this one here, I'm going to go ahead and write it with fractional exponents. And in this case, I'm trying to simplify my 4, so I wrote it as a smallest power I could, which would be 2 to the power. And you could apply that exponent of 1/6 to each one. So then I get 2 to the 1/3 and x to the 2/3. Well, I started out with roots. I want to leave my answer with roots. So you want to go ahead then and write it as a cube root because the bottom part means cube root. It would be a 2 to the first and then an x to the second. Notice in the one over here, we started out with roots. You want to leave your answer with roots, so your answer would be the cube root of 2. Here, simplifying this, it's really a 2 squared, and it's raised to the 1/4 power. Well, you multiply your exponents, and you just get a 1/2. So you get a 2 to the 1/2 over a 2 to the 1/2. Top and bottom are the same, so you just get 1. This one here can be done with fractional exponents, and it would look like this. Oh, then we want to go ahead and write this back in terms of roots. But this exponent's bigger than 1, so I'm going to write that as a 2 to the first and times a 2 to the 1/3. Now, the parts that have the 1/3 on, you can go ahead and put those in the root and leave this 2 in front. I really think this problem is done easier without fractional exponents. So I would just go ahead and do it like we've done in the past and write the inside as perfect cubes and then pull out my cube and I would have this.